Hawaii is a favorite destination for millions of travelers. But each month, the full moon brings a unique group of visitors to paradise. An influx of Alatina alata, or the Hawaiian box jellyfish. Dr. Angel Yanagihara of the Johnny Burns School of Medicine has dedicated herself to researching this intriguing species and applying her discoveries to medicine.
Over the last 17 years, I've been looking at the Hawaiian box jellyfish. It's an animal called Alatina alata, and specifically I've been looking at the venom. I'm a biochemist, so my primary interest has been in taking it apart and figuring out what particular biomolecules make up this venom. I myself ended up in an ambulance, and I had passed out. I was wrapped with saran wrap and vinegar and all these, tubes, etc., coming in and out. And I really thought, what in the world are they doing? Well, I never intended this to be a lifelong research path, but as a biochemist, I was stung, and that intense pain, was basically feeling like thousands of matchsticks on my neck, got my full attention. And my primary initial interest was just to do a quick literature search. I thought it would be already published and the answers would be out there, and just to answer my own curiosity. When I did a literature search, though, I found there was no answer already known. So that actually got more of my curiosities. The 7th to 11th days after each full moon, we look at the tidal schedule and all these different factors, and we basically go out to the beach during the night drop from high tide to low tide, and we are walking up along this control area off of Waikiki Beach that has been looked at every single month without fail since 1997. In addition to that, we may survey other beaches, but we collect every single animal on those beaches during that time period, and then we report those numbers to Ocean Safety. There's over 60 box jelly species. Only one of them has this unique spawning cycle where they come in the middle of the night from the deep ocean, swimming over a mile offshore to these particular beaches. All the other species have very different life cycles and field ecologies. So when we're out there, the 7 to 11 days after each full moon, there's only one species that's coming ashore, and it's this Alatina alata. The first experiment I did, while there was no published declarative statement as to what was causing this in these animals, there was a hypothesis that there was a yet to be discovered ion channel blocker, some mysterious silver bullet. So I started out with experiments designed to look for ion channel blockers. The very first experiment, though, was a complete catastrophe, because as soon as I added the venom, I had what is called leak current. And this is a non-specific non-starter, basically. Once you have a leak current, you can't do anything more. I went into different approaches to look for bioactive compounds. But at the end of the day, at the end of 17 years, I find, in fact, that protein that was causing the leak current is actually the locomotive that drives the whole train. So it's a pretty ironic circling path. It wasn't at all the linear plan I had in mind, but that was the beginning, and that turned out to be the answer. Well, I think my major accomplishment at this point is survival. just continue keeping my enterprise going forward. I get no dedicated institutional support, so I'm what they call soft money. So for 17 years I've brought in my own salary, my staff salary, my equipment, my supplies. So just keeping that enterprise going and writing enough grants to do that is a major accomplishment. I mean, it's actually very difficult. But I have been, of course, passionate about answering this question, and I have really enjoyed the process, and I think that's probably what I'm most pleased with is just to be able to look back and to learn from the process itself. The process itself has sort of brought its own benefits, and these are all very enriching things that I have learned. And I think to draw students in, I've had numerous undergraduates and graduate students along the way, postdocs, into this enterprise of discovery is also something that's an accomplishment, and I really appreciate being a part of that process. We're dealing with a far more ancient type of venom. In fact, it's one of the first animals on the planet, just after sponges. So we have a very primitive life form, and these 17 years of deconstructing this complex venom have shown that the bioactive constituents, actually a lot of them are far more similar to pathogenic bacteria. My work really has clarified what is the fastest acting agent, and then having determined that, I went through hundreds of compounds to figure out how we could inhibit that. So now I have developed multiple technologies towards that, and that those are all these intellectual property IPs that are now in the pipeline to get out to the commercial marketplace. Unfortunately, that's its own slow process, but yeah, no, we're in the middle of that, and I'm very happy about that.